So guys, now let us discuss next how virtual addresses are mapped to physical addresses. So let us discuss virtual addresses to physical address mapping. So on the right hand side you can see a diagram which represents a process in execution. So we already know that process virtual address space is split up into various segments. The bottommost is the code segment, followed by data segment, followed by heap segment, and then you have an empty space which is reserved for heap growth, and then followed by stack segment which grows downwards. Now let us suppose that during the course of execution of a process, your process requests 20 bytes of memory using malloc. So let us suppose that malloc returns some address. So if the address that is indicated by PTR points to address location, say this, right? So this address will be some address in heap segment of the process virtual address space. So you can see in the diagram on the right hand side that the heap segment has expanded by 20 bytes, and the starting address of this 20 bytes is the address which is returned by malloc. So the content of this PTR variable will be this address. Now suppose your program invokes a write operation to this memory location. So let us say that you are simply writing a string hello to this address. So as soon as you perform any write or read operation on this virtual address, what happens on the operating system that this virtual address is converted into corresponding physical address by MMU. MMU stands for Memory Management Unit, and the concept of translating virtual address to physical address is called paging. So you can see that MMU is a component which resides in the operating system, and for every virtual address that is generated by running process, MMU converts this virtual address into corresponding physical address. Now by definition, physical address is nothing but it is a location of a byte on a physical memory. Now your physical memory is nothing but it is a RAM. So it is the actual physical hardware memory which is installed in your system, and every byte of this physical memory has a physical address which is constant and it never changes. So MMU translates the virtual address that is generated by running process into its corresponding physical address, and the write operation is actually performed on this physical address. So it means that the data is actually written into the physical memory. Note that virtual memory do not store any data. At the end of the day, the data will be written in the physical memory at the address which is mapped from the corresponding virtual address. So never ever say that hello is written in the virtual memory. No, that is wrong. Any data always resides in the physical memory. Virtual memory is a concept. Virtual memory is not a real memory, or it is not an actual piece of hardware that can store your data. At the end of the day, the data needs to be stored in the physical memory. So in this slide, at a very high level, we have discussed the role of MMU. In the preceding slides or lectures, we will discuss that how this translation from virtual address to physical address actually happens. For now, I have just chosen a random physical address and a random virtual address. So actual data or content is written on the physical memory. Virtual memory do not contain any data. So same goes with any address which belongs to the process stack memory, or any address which belongs to the data segment of the process. In fact, any virtual address which belongs to the virtual address space of the process undergoes through the paging and maps to an actual physical address on the main memory. So in this example, I have taken an address which belongs to the heap segment of the process, but the mapping of virtual address to physical address applies to any virtual address which belongs to any portion of the process virtual address space. This virtual address could be an address which belongs to the heap segment of the process. This virtual address could be an address which belongs to the data segment of the process or code segment of the process. So now let us try to visualize the relationship between the virtual address and physical address with the help of an analogy. Consider virtual address as keys. So you have some keys and consider virtual address that belongs to the process virtual address space as some sort of keys. Now if you have keys, then there has to be a lockers in which you can keep your data items. So consider lockers as actual storage on physical memory where process data is actually kept. And consider the memory management unit as a mechanism which maps that which key belongs to which locker. So again I'm emphasizing virtual memory do not contain any data. It is the physical memory which eventually stores the data. Virtual address is just a mechanism which takes you to the actual location in the physical memory with the help of paging. So this analogy clearly explains the relationship between virtual address, the physical address, and the paging, which acts as a bridge between virtual address and physical address and facilitate mapping from virtual address to physical address.